I'm Harold Campbell, and I'm a developer at ThoughtWorks. And I've been doing development for quite a while, and today I'd like to just share my views on using anemic components for rich data presentation. If at any point you can't hear what I'm saying or there's a language impediment, just raise your hands aggressively so I can know that or repeat what I'm saying. All right. Everybody clear? Cool? Sweet. So before we jump in and start looking at anemic components, let's talk briefly about why there's an argument for using ES6 to do rich data presentation. ES6 is otherwise known as ECMAScript 2015. And from my perspective and from the work that I do, I found that just using pure JavaScript, pure ES6, makes it easy to go from an idea to actually having working software. And then because of the fact that most modern browsers support ES6, then you can go from working software that I can hack around and show my friends to actually something that I can push out really quickly to a customer. And then you have developer experience. Because you don't necessarily need this complicated build stack or build process, you have your ES6, your JavaScript file, you have a web server, and you have a browser. That's literally everything that you need. So your developer experience tends to be better than having to use, say, TypeScript or CoffeeScript or so forth. So there's a valid argument presently for writing most of your applications in pure JavaScript. So from a personal experience, some of my favorite features, and this is by no means an exhaustive list of the features that are present in ES6, but some of my favorite features are your string interpolation, where in the first example, if you were trying to build an SVG path, you'd have to go string, then plus, then the variable, then plus, then string, and so forth. With ES6, you can simply use the $ curly bracket notation and build your string really quickly. And it tends to be clearer. And this is supported natively by the browsers, the modern browsers, I should say. Then you have these structuring assignments. In the first example, can everybody see the text? Is it large enough? All right, great. In the first example, we have a bunch of objects in a line, in an array. And if I wanted to extract the particular properties, which is P1 and P2, I'd have to first assign to some intermediate object and then call the properties. With destructuring, I can simply put the names of the properties in the curly bracket, assign something to it, and I have direct access to two new variables or whatever amount of variables that represent those properties. It's also really cool if you're doing, if you're using anonymous functions or lambdas, where we can use destructuring in the actual parameters, and then we'll access the variables, the parameters as variables. So in this example, we have a pipeline that we're pushing stuff into, objects into, and then we can just pull out the properties as variables. Then we have spread syntax. So the first time I saw this, I was like really excited. So in the code that I use, I have something and I wanted to get the first variable. And then I wanted to clump everything else so I could use it elsewhere. With a spread syntax, you can simply say exactly that. Give me the first thing. And then the orange bit is the spread. Everything else gets clumped together. So when you're assigning the visuals array to the thing on the left, you get the first thing and everything else on the left. So thinking about this makes it really simple about what your intent is with the code. And then the second example, if you have an array and you need to pass that array into a function that has multiple variables or is variadic, you could then use the spread syntax. The alternative, if you weren't doing the spread syntax, you'd either use a filter on the array or use an apply method like what we're doing in the comments. And then you have the arrow function, right? The arrow function is just a simpler way of representing the function block. You get rid of the function keyword, and then you just have the arrow, and you can put the list of variables or the list of arguments. But there are downsides to using the arrow, excuse me, the arrow syntax, where the this argument, super, and new properties, they're not bound to the arrow. It actually doesn't create these new variables. It uses lexical scoping. So you just have to watch out for that. And then you have object notation. If you deal with a lot of JavaScript or JSON, this particular comes in handy. In the first case, we have a property in the object, data, called data. And if the variable or the thing that we're assigning has the same name as that particular property, then you can just drop the actual variable. Similarly, you can get rid of the function keyword and just call the action. So with JSON, when you had the GraphQL, this would have come in handy in reducing the amount of work that you would have had to have done. So, sweet. ES script saves the world. Everything is going to be great if we use ES6. But what about rich data presentation? I mean, why? How does that fit into the picture? Well, you know, when we think about rich data presentation, we tend to think about these things. You see a lot of these kinds of dashboards online. People are saying, look, I have a pretty visual and it's rich data. Actually, no. Rich data is all about revealing the relationships between hidden in the complexities of the data. Right? So you see why I said no, right? What about this? Would this be a rich data presentation? Yes, no, shout? Yes, I think so, right? We have three variables here that we're presenting. There's a date, the day of the week, and then the frequency of some activity. So this is a good example, I think, of data with complexity. It's not overly complex, but the visual that you see obscures some of that complexity, and it makes it easier to focus on what you're trying to communicate. Here's another example of a rich data presentation where we're looking again at a time-based data where we have some categories of tweet, and we're looking at those versus the time versus day of the week, and then different categories of tweeting activity. Tweeting activity, that word, okay. And then another, and this now is really complicated. This one shows American spending across different categories, and then the different departments, and then how that relates to the type of spending. It's unimportant about what the actual thing is, but see that there's complex relationships that we can actually see in a very clear and meaningful manner. So your current options for trying to do this kind of thing on the web is D3, 3JS, Snap SVG, and so forth. But these libraries are best suited for doing these types of visuals. With D3, who's the granddaddy of all of this, you can do compelling visualization. You can present data, present rich data. In fact, this example is from their website, and each hexagon is a different type of data presentation. But it takes that code on the right, number 2, to create that simple example. I wouldn't want to know how much code would be required to do that. In fact, this was actually created with a desktop application called Gphy. So the current options, there are pros and cons, obviously, right? They're difficult to learn. They're hard to test and debug, or I should say the resulting visual is hard to test and debug. And it's hard to then expand the visual to add new functionality. Yes, there are some pros, but I disagree with some of those. So from my perspective, then we have to ask a question: what am I trying to do? What work am I doing, and what do I want? So it's all about the kinds of abstractions that are going to allow me to focus on the work that I'm doing, and then how easy it is to do that work. So that's where you have a bias towards simplicity and clarity. So if you're using anemic components, or if you're building your own anemic components, there are a bunch of things that you should try to do. So for one, you should do one thing well. Your components should do one thing well. And in this case, the anemic component is bars, right? And then there's some side effects that we inject into it. So we can set the max height. So the max height of any of the bars will be no larger than 50 pixels, regardless of the data. There's a Y offset that dictates how the thing is stacked, and then there's a width. If we wanted to change the behavior of bars, we added an additional side effect. In this case, we are now saying offset each thing incrementally by 30 pixels horizontally. And again, just to drive the point home, by changing the side effect, change the entire visual altogether. And in this case, all we've done is gotten rid of the Y offset, and we've changed the width. The things should be testable, right? And from my perspective, building testable components spans two core ideas. You have single responsibility. Each of your components or side effects, or whatever you're building, it should do one thing. It should have one single responsibility. Therefore, you can reason and test that particular thing. You don't have a conflation of problems. You should try and favor having dependency injection. And this is literally just decoupling the different parts of your application so you can stub and test the different parts that you've written. And that's where that single responsibility comes into play. And this is actually code from the engine this is a core part of the code that renders everything that I did. And then you want to have a limited API. So we saw with D3 and the others, their API list looks like that. It's ridiculously huge. But if we have a small API, then it's easier to learn what is being done. It's easier to communicate what your library is doing, what your project is doing. And then it's easier to test because we have these little pieces that we can test and separate. And then you can deliver faster, which means you can build something, push it to the market, and get faster feedback. And then you have this virtuous feedback loop. To me, that gives us good developer experience. And then finally, is it finally? No. But then, the thing should be pluggable. If you're building anemic components, you want them to be pluggable, where I can build the core part and then extend it by injecting new behavior. Right? So that you don't have the side effects having side effects. Does that make sense? Yes? All right, cool. And then, of course, and I'm not 100% sure with this one yet, but you want the thing to be, a side effect of it being pluggable is that I can have composable structures. So presently, each of these disks is made up of several other individual things. I could actually put all of that as one new functionality and expose that to third-party developers. And then focus on use the right tools, right? Use CSS for doing your styling. Don't style or try to avoid using code to do styling. Use CSS. Because it's easy, for one, and you want to have separation of control. Behavior is in one place, styling is in one place. In my case, I had to break that to some extent because there are some limitations in using using CSS for styling SVG, specifically the Z order index. So, this guy. If I wanted to reason about this visual, right, there are a bunch of things that I have to think about. There's firstly the intent. And it's a bunch of bars stacked vertically, a bunch of ellipses also stacked vertically, and then the ellipses are connected by lines. So what would the code for that look like? Well, it's this. It's some bars, and they're stacked vertically. There are some ellipses, they're stacked vertically. And then there's some connecting lines. It's straightforward. Simplicity. The shape on the right, regardless of how complicated it is, it's made up of three fundamental primitives, right? Bars, ellipses, and lines. And yes, you could actually argue that your bars are just fat lines, but for the purpose of this conversation, all right, we have three shapes. We have some bars, we have some ellipses, we have some lines. Again, we have some bars, we have some ellipses, we have some lines. So it makes it easy to reason about what we're trying to do. It makes it easy to understand what the code is. So there's that one-to-one mapping between my visual and my implementation. And then clarity. And this one is a bit sketchy, right? So we have one group of some things that start vertically, two groups of some other things start vertically, and then we have connecting lines. And the reason why I'm saying that this is kind of sketchy is that's my interpretation of this visual. It could have been that these things were stacked that way, right? True? But if we used this frame of reference, then again, the code is pretty straightforward. There's a group of bars, there's a vertical stacking, there are groups of ellipses, E1 and E2, and then they're joined. So, and it says so, join groups, items, E1 and E2. So, coming back to this friend of ours, and let's just spend a quick minute looking at this friend of ours. We want six horizontal bars. Immediately in looking at the code, it's not obvious that that's what we're doing, right? And even if we wanted to figure out how do I test it, how do I test the width, the size, and so forth, again, it's not obvious how I would do that. Coming back to this example, if we needed to test the width element or the width side effect, how do we do that? If we wanted to play with different elements of this, because each thing it has one responsibility, because each of them changes one attribute of your code, then it's easy to pull that thing out, to test it, swap it around, and do experiments. Make sense? Yeah. So when you're building rich data oh my God, let's try this again. When you're building rich data presentations, err on the side of creating composable components, or anemic components, because they do one thing and they do one thing well. They were designed to be tested, or you will design them to be tested, right guys? Sweet, all right. They have a limited API, and in the case that we're seeing, the bars object actually doesn't have an API, it has zero API. And I know we can argue over bears whether those side effects constitute an API, but from my perspective, they don't. All the bars knows how to do is draw bars. It doesn't expose any APIs externally. And then you want to have pluggable side effects. By having pluggable side effects, you can then change the thing without worrying about what else am I breaking. Everybody cool? All right. So here are some resources, and what I'd like to do briefly, let me just see how much time we have to jump through this. What I'd like to do briefly is just switch to Atom and show you some code. Is everyone cool with that? Cool. So that's the code for bars. It takes in some data, and it takes an effects array. And in the as normalized, we go through and we normalize the data. So we don't really care how the data is defined. And then we call a primitive, and the important part is at the bottom where we have that pipeline, and we're pushing the objects, which are the visuals, into that pipeline here on line 553. We do nothing with the effects because the bars doesn't care about the effects. It's only concerned about how do I draw the bars. Guys, if this doesn't make sense or you want to ask a question while we're going through this, just raise your hand up. Cool? All right. If we were to look at was it a hand? Okay. The ellipses, drawing ellipses is similar. It's a similar pattern. We have a function, we normalize the data, we call some primitives several times, we build a visuals array on line 75, and then we hand off to a pipeline. And as you can expect, the connecting lines should be similar, right? You see the pattern. It does one thing. It normalizes the data. It calls something that knows how to build these primitives, and then it hands off to an engine. What does the engine look like? Oh, let's look at those side effects before we go through. This is core, sorry. So this is the X side effect. And this one, the X side effect says, go through and take all the visuals and move them to the X position. The code is pretty clear. And here we're using the object notations that we saw earlier, right? We set the data, we define an action that literally, for each visual, set the X position. We have, for the Y offset, the one that created this vertical stack. It does one thing. It goes through, it finds the first thing, and then it goes through and pushes everything down based on that. There's no magic. And then the pipeline, the actual heart or core of everything is literally that. In fact, it's that. If I weren't lazy, we could have cleaned up some of the code, but I was lazy. It's literally that. We take the effects that we come through. So the visuals create themselves, and then we have the effects, and we use dependency injection, we use dependency inversion to ensure that we have an interface model, and we call effect action on all our visuals, and that will then dictate how the things are shaped or modified. So that's why I was saying that the actual shapes themselves, they don't have an API because they don't care, right? And the actual code that generated, are you still working? Are you here? The actual code that generates this image, ignoring the data, is literally only that, right? And it's literally that. The bars, heights, saying where it should go, and that's it. Switching back. So, resources. Where do you find or learn more about ES6? I find the ES6 features to be particularly useful, and apart from just writing the code in your browser and getting an undefined or an exception, you can use can I use. If you're on Chrome or doing most of your development on Chrome, you can use Chrome status. Of course, there's Mozilla, and for a quick prep on JavaScript, you don't know JavaScript, it's pretty good. Thank you. Any questions? So it's going to be open source, but it's not open source yet. But if you follow me on GitHub or just tweet at me, I'll send it to you when it's there. So I have no tests, all right? And I'm somewhat embarrassed by this. But it's designed to be testable, I promise you. But I just have no tests, because I was aggressively going through and changing different things and saying, can I do this? How would the API look? Because I designed this from the API outwards. Unfortunately, I don't have, I designed it from here outwards. So I designed it from my starting point, and work backwards. So in a week or two, it will be up there. I need a name. So presently I'm thinking of anemic UI, but I'm not sure. What do you guys think? Any better suggestions? I'd be happy to hear. No? Anything? All right. Any other questions? In ES6, the import, it doesn't support imports presently. So literally we have utils, core, and intents, and then you can build your own intents. I haven't started grouping the intents into different types of intents, but I will at some point. Or you can send me a push request and we can figure it out. Yeah, open source it first. Any other questions? simply because I'm more comfortable writing that way. But I didn't want to say it's functional programming because we had side effects. But it is definitely influenced by functional programming. All right. So ideally, if we could, I would go fully functional, and I'd be happy to convert to that. All right. No more questions? All right, cool. Thank you, guys. Have an awesome day.